Hello, so now we're going to cover how to use an atomic absorption spectrometer. So it's a pretty hefty instrument. There's a lot of components behind it, which you won't have to worry about. Your TA will have everything set up for you. So in this section here is your hollow cathode lamp, which provides your wavelength. You can also make sure the wavelength will be set here, but your TA will do that. Inside here, you have your burner, and this is where your premixer and aspirator, where your sample is going to be sucked up to go into the flame. And in here, in this part of the instrument, you have your monochromator, your detector, and your amplifier, just to give you a signal. So it all pretty much, all those components allow you to give an absorbance reading here. So those are pretty much the main components. There's a lot of knobs and stuff, but again, you don't have to worry about that for sampling. So just to start up the instrument, give me some oxidized air. Just use a regular sparker. And that's what your flame looks like. You get used to the pump in the background. It's quite warm, so you want to keep the door closed once you have it ignited. You already have all your standards prepared. You want to start off with your zero because you want to zero the machine. So it's really simple. This is just your nozzle. You insert the straw into your sample, and it automatically sucks up your sample, aspirates it into the flame to create atoms. This is how we atomize your sample, and then once your sample is being ingested by the flame, press auto zero to make sure your background is corrected for. So once that's accomplished, then it's just really a matter of measuring each standard relatively quickly, since your absorbance is an instant reading. So just sticking that in there, and then you'll see an increase in your absorbance. And it's that quick. If you find your numbers fluctuating a lot, feel free to, at any time, take your zero, and you can zero the machine at any time, just to make sure your background is relatively the same for all your standard readings. And then you would continue with the rest of your standards, and now you have enough data to build a calibration curve and measure your unknown.